So hello friends, today we will be solving this another question, and in this question what we are asked is we have to find out the length of this rod. Let's assume it is L, and now let's read the question. A thin uniform rod AB of mass m equal to 1 kg moves translationally with acceleration equal to 2 meter per second square due to two anti-parallel forces F1 and F2. The distance between the points at which these forces are applied is equal to A equal to 20 centimeter. Besides, it is known that F2 equal to 5 Newton. Find the length of the rod. Okay. So A equal to 20 centimeter or 0.2 meter. Right. And what we are given, F2 equal to 5 Newton. And this rod is accelerating with W equal to 2 meter per second square. M equal to 1 kg. And we have to find out the length of this rod. So how to do this question? So this question covers a very critical concept, and the concept is the acceleration or the torque balance equations in the non-inertial frame. So we will be covering that concept, and it is very important for JEE Advanced, JEE Mains, and all other competitive exams. So let's cover that concept in this question. So first of all, as the question says that the rod is moving only translationally, it is not said anywhere that it is rotating, which means that all the torques are balanced about any point in the rod and outside the rod, right? So we will be balancing the torque about the center of mass of this rod, and after that, to clear our concept furthermore, we will be balancing at some other point. Let's maybe at point B or point A. So first of all, let's begin with the torque balance about center of mass of this rod. So this is rod. This is its center of mass, and one force is acting at F2, another is at F1. So first torque balance equation, let's say this length is L by 2. So balancing torque about this point, F1 into L by 2 L by 2 minus A. So from this equation what we can say is F1 minus F2 L by 2 equal to minus F2A. So this is our first equation. Another equation we will get from writing the force equation, that is force equal to ma. So yeah, to write that equation, what we can observe one thing in this, that this was rod, this was force acting on it F1, and this was F2. So and also you can observe this from this equation, but let's try to observe from the diagram that I am asserting that F2 would be greater than F1. I am asserting that, and if you are able to find out why, then yeah, that is great. But I will be also explaining why. So F2 is greater than F1 because torque is balanced about this point, right? About O point. So this means that the moment of both the forces is equal, right? So as F2 is at lesser distance from O, it must be greater than F1, right? So try to think what I said, that moments are equal of both of the forces. So the force that is closer to point A would be greater, as its distance is lesser, so it must be greater than another force. That's why F2 is greater than F1. So we can say from this that this rod would be moving in the direction of F2 because it is greater. So what we can write from here, F2 minus F1 equal to mass into W, right? So yeah, and from equation number 1, F1 minus F2 equal to minus F2A upon 2 F2A upon L. So putting this into this, 2F2A upon L equal to mass into W. So from here you will get the value of F2, that is equal to MWL by 2A. Yeah, I think, yeah, oh sorry, we were asked to find the value of L. So L equal to 2F2A upon MW. So this is the value of L. So now finding or applying the torque equation about point P, right? We will be applying about point P. So this is point B, right? So yeah, let me draw the diagram again. This is point B. F1 is acting here. F2 is acting here. And this was the center of rod. Let's name it as O. Okay. Yeah. Now keep in mind that this point is accelerating. This whole rod is accelerating. So point B would be also accelerating, right? So whenever we write a torque equation in the frame of a point that is accelerating, then we must apply pseudo force on all other things that are present in our system, right? So we will be applying pseudo force on the center of this rod, because pseudo force is applied on the center of mass of other things, right? So we will be applying a pseudo force on this center. So what is the value of pseudo force? Pseudo force is equal to acceleration of the accelerating frame into the mass of the thing that we are applying pseudo force on, right? So pseudo force value would be equal to mass into omega, W, and it would be in the opposite direction of the acceleration of point that we are applying, the reference point or the observer point, right? So pseudo force would be in this direction, and F1 and F2, right? So now balancing torque about point P. So as you can see, what is the equation? F1 into L, as this is L, plus mw into L by 2 plus equal to F2 into L by 2, into L minus A, because this is A. So from here what we can see is we can write the value of L equal to, taking everything towards the LHS, L plus MW L by 2 minus F2 L equal to minus F2A. So L equal to minus F2A upon F1 plus MW by 2 minus F2, right? So this is the value of L. But we have to put MW, what we have to remove this, right? So what we can put, wait a minute, we have calculated here where it is coming. The force equation I'm trying to find, here it is. F2 minus F1 equal to MW. So yeah, we will put this into our final equation, F2 minus F1 equal to MW. So here we can write minus F2A NSEP to this will be minus mw plus mw by 2, right? So it is equal to 2f2a by mw. So as you can see, our final answer is same as above. Now you might be having one doubt that while we applied torque equation in the about center of mass, we didn't consider the pseudo force. Even the center of mass was also accelerating as the rod is accelerating. So why didn't we consider the pseudo force about that point while writing the torque equation about that point? So my answer is simple, that you should be considering the pseudo force in that case also, but it doesn't matter. It does not matter. Even if you have applied the pseudo force during that torque balance equations, it would have passed through the to the center of mass of this rod, and eventually the torque would have came out to be zero. Torque due to that pseudo force would be zero because the distance is zero from the center of mass. So what I am trying to say is that even if you have considered a pseudo force, then it would have passed from this point, right? And its value would be m into w. But while adding the torque of this force about this point, as you can see, distance is zero between the point and the force, then its torque would be eventually zero, and it won't create a role, or it won't occur in the torque equation. So that's why we were getting our answer. It was not affecting our answer here. So yeah, so that is all, and I hope you have understood the how to write torque equations in non-inertial frame when the point is accelerating. So I hope you have understood that, and yeah, let's meet in some another video, right?